This problem is still from Cambridge Mechanics book. So this problem is about solving a three-force equilibrium problem using Lami'S theorem. Solve the problem. The problem says a ship is held in equilibrium by ropes on bearings of 120 degrees and 220 degrees. The wind is blowing due north and exerting a force of 19 Newton on the ship. Find the tension in the two ropes. So in this problem, the diagram is not given. So what we're going to do, first things first, is that we need to construct or we need to draw the diagram. So let's start. So based on the problem, a ship is held in equilibrium. So by ropes with bearings 120 and 220 degrees. Okay, let's start. So the dot, let's draw a dot. So the dot here can represent the ship is held. So again, since we are talking about bearings, so let's try to draw a north. Because bearings are always measured clockwise. Okay. Now, so it says here, the wind is blowing due north and exerting a force of 19 Newton. So we already have an idea that one of the forces is due north and it has 90 Newton. So that's a good thing. So this will be 90 Newton. Next, let's try to measure. There's a bearing of 120 degrees. So let's construct. Approximately 120 degrees is around here. Approximately this is around 120 degrees. Okay, let's try to draw the angles 120 degrees. So this is 120 degrees. Next, the other bearing is 220 degrees. So if this is 120 degrees, so therefore we can approximate 220 degrees will be approximately here. Let's make it straight. Okay, 220 degrees will be approximately here. So we can say that this will be 100 degrees up to here. So let's name it as our the first row, or let's say tension, because it's asking for the tension. So T1, T sub 1, and this will be your T sub 2. Now the direction will be going this way and this way. Okay, so that will be our diagram. Now, in this problem, we can make use of your Lami's theorem since, as you can see here, there are two angles given. First angle is opposite the 19 Newton. First angle is opposite the 19 Newton. And the second angle is opposite the T sub 2. So Lami's theorem states that Lami's theorem again states that A all over sine of alpha is equal to B all over the sine of the beta, and the C is equal to the sine of the gamma. Okay, so that is your Lami's theorem. It's quite similar to your sine law, actually. Now, so let's start. Let's start to find uh, tension, the first tension, or T sub 1. Okay. So we're going to find the T sub 1. So what we're going to do is, as what I've said, the same, almost similar to your sine law. What we're going to do is, we're going to get a pair of a force and an angle. So we can make use of this one, of the 90 and 100. So we can have 90 all over sine 100. So that would be equal to, so let's solve for T sub 1. So all over your sine 140 degrees. So this will be sine 140 degrees. How did we know that this is already sine 140 degrees? So we get 140 degrees here by calculating. Remember that one complete revolution is equal to 360 degrees. So this is just 360 minus 120 minus 100. So 120 and 100, that will be 220. So to get this side here, or this angle here, I mean, that will only be 360 minus 220. So that's why we can write here sine over 100. I mean T sub 1 all over sine 140. Now, let's do cross multiplication. So if we're going to have cross multiplication, that will be equal to T sub 1 sine 100 is equal to your 90 sine 140. So therefore, to solve for your T sub 1, or the first tension there, you can have 90 sine 140 all over sine 100. Now, let's choose the calculator. So 90, again, don't forget to set your calculator to degrees. Sine 140 divided by sine 100. So the answer is, we're going to set it to 2 decimal place. That will be 58.74 Newton. So this one will be 58.74 Newton. So this is the answer for the first tension that is unknown. So this is just losing your Lami's theorem. Next, let's solve the T sub 2, or the tension in the second row. So to solve it, so again, what we're going to do is just to get a pair of side and angle. So let's use this one. So we can have 90 all over sine 100. This is the same pair that we use on the other side. So that would be equal to, so we have your T sub 2 all over sine 120 degrees. Okay, that's sine 120 degrees. Now, cross multiply, same process. So if we're going to do cross multiplication, you will arrive with T sub 2 sine 100. That would be 90 sine 120 degrees. So with that, we will have T sub 2 is equal to 90 sine 120 degrees all over sine 100. Okay, the sine 100 degrees. Now, so we will arrive. So use your calculator to compute. So that would be 90 sine 120 divided by sine 100. We will have around 79.14 Newton in 2 decimal place. 79.14 Newton. Okay, so we're done with the problem involving three forces in equilibrium using the Lami's theorem.